STEM Adventure, Revision Notes, OCR A-Level Physics, Motion. Over 25% of the OCR physics syllabus is about motion in one form or another, so understanding and memorizing the core framework of motion is critical. Let's start with displacement time graphs. We need to understand how the shape of the graph can let us understand if the motion is, for example, constant velocity or acceleration. Also remember that the graph can indicate if the velocity is positive or negative. This can be understood in detail from the gradient of the graph, which is equal to the velocity. Remember that the velocity time graph will look different to the displacement time graph for the same motion. And for the velocity time graphs, the gradient is equal to the acceleration, and the area under the line is equal to the displacement. When you encounter a graph for motion, ensure that you check which type it is. A common mistake is to assume it is a displacement time graph, when actually it is a velocity time graph, or vice versa. The Suvat equations are invaluable for questions involving constant acceleration. These are often for objects moving in a uniform field. The equations are all in your databook. Things to remember when using these equations include acceleration, velocity and displacement are all vectors, so ensure you set a positive and negative direction from the start. There are many methods that can be used for measuring acceleration, ranging from light gates to ticker tape. Make sure you have a knowledge of one or two of these to use in a practical description question. Lots to remember here. Projectile motion is a favorite question topic as it combines so many motion concepts. For these types of questions, we need to consider two directions, vertical and horizontal. As the object undergoing projectile motion moves through its path, the vertical component of velocity changes as the force of gravity acting down gives an associated acceleration down. So as its height increases, its vertical velocity decreases. The horizontal component doesn't change as no forces act in this direction, assuming no air resistance. At the top of the motion, the vertical component of the velocity is zero, and its vertical displacement is maximum. Then, as the object falls back down to Earth, the vertical component of velocity changes direction and increases again. We use the Suvat equations for the vertical component of the velocity, but it is critical that we set a positive and negative direction, and remember that acceleration always acts down. Finally, for this topic, we need to know the factors affecting stopping distance for cars undergoing braking. These are listed here. Lots to memorize. Don't forget that all our resources, including revision notes, flashcards, multiple choice questions, and past paper questions, are available on our website.